Okay, welcome back. Today we're gonna solve some integrals, but we're gonna use some different other techniques, and I'm gonna be going over a specific technique that you may or may not see, and you definitely, if you're in college, you've definitely seen this. But with a high school calculus class that I'm taking it, it's like no one ever uses it. So like I'm gonna like put you guys on if you ever get stuck on types of problems like these, and then you can like use this technique to solve. Hopefully it will make your life easier. Okay, so let's start. I also, every time I do these types of problems, I recommend you guys pause and do it on your own, because if you just listen to me yip yap for a couple of minutes or maybe like 10 minutes and you're not learning anything. Okay, so I would recommend you guys to like do the problem. So in fact, do it right now. Done? Alright. This is just to check. Okay, first thing is this radical expression. It looks ugly. And I can't just do a substitution and let the inside equal to u, because it doesn't have enough, like it's not enough. Again, minus 2 plus 2, that's too much. No. So one thing I'm thinking of is I can complete the square and see where that takes me. So I can like maybe make it a little more cleaner. So let's do that. Let's complete the square. Okay. 8 minus 2x minus x squared. This is the same as 9 minus 1. Yeah. Everyone knows 9 minus 1 is 8, but I know 8 is 9 minus 1. Minus 2x minus x squared. This is a perfect square. Okay, this you could factor a negative 1, right? At least I'm talking about here. You can factor a negative 1 and you're gonna get 9 minus this in terms of a perfect square. Okay, so let's put this back in and see if we can get anywhere. X over square root of 9 minus x plus 1 squared. Nice. Can't forget the dx. Okay. I don't like this x plus 1 here. That's just me personally though, but I don't like this x plus 1. So maybe I can like make a dummy variable that shifts this x plus 1 to the top. Let's do that. You know what? Let's do that. Let's say u is x plus 1, which implies that here's a trick. U plus 1 equals x. Aha. And right here. So that's perfect. So I can get less fluff out of the radical. U plus 1 over square root of 9 minus u squared. Perfect. Du. I should mention that du is obviously equal to dx because it's a linear relationship. Okay, so here's the technique that I'm thinking of. I have a radical here, and I see a square inside that radical. Maybe life would be much more easier if I had a cosine or something in that radical. If I had a cosine, specifically 9 cosine squared, maybe I can, or better yet, 9 sine squared. If I have 9 sine squared, I can consider this would turn into 9 times cosine squared, and cosine can be easily written as an inverse, as from pi over 2 to negative pi over 2. Actually, it should be the opposite, but you know, and its inverse is within that range, which is like really convenient because the absolute value that you get from the square root also is the same over that period. So if I can get a cosine in there, and if I can get the square root of cosine squared, my life would be just so easier because that radical will just go away. Yep, I gave it to you. This is what I call Trig Sub. Actually, this is what everyone calls Trig Sub, but we're gonna do it. So we're gonna do u equal to, we're gonna let u equal to 9 sine theta. and we're gonna let du equal to 9 cosine theta. Okay, so let's sub this in now. Oh, is it? Oh, you know what? I think you already got it. Anyways, integral. Okay, that is 3 sine theta plus 1 over square root of 9 minus this square. So, hold on, let me write it out for you guys. U squared would be 9 sine squared theta. So let's write that down. Right, and d theta is 3 cosine theta. D theta. Okay, let's move this integral here so I have more space for y'all. Let me rewrite it real quick. Nice. Okay, so now let's do the strategy that I was talking about. We can factor the 9 and we're going to get 1 minus sine squared theta. It's right here. Factor the 9 and we're going to get 1 minus sine squared theta, which is really conveniently, this is 9 cosine squared theta. Aha. Okay, so now if we take the square root of that, in fact, if we take the square root of that, we get this. They cancel out. Perfect. So let's act it out right now. 3 sine theta plus 1 over, so remember we simplified this to this. This is the square root of 9 sine, that's cosine, my bad. 9 cosine squared theta, and this is 3 cosine theta, d theta. This is nothing but 3 sine theta plus 1 over 3 cosine theta and 3 cosine theta. Now, magic happens. These nicely cancel out. Now we have 3 sine theta plus 1, which is a very easy integral to solve. So yeah, we can do that really quickly. Let's just do this in our heads. I don't have to write it out again. Integral of sine theta is negative cosine theta, negative 3 cosine theta, and the integral of 1 is theta. Now, let's do we need to go back to the x world. Okay, we know u is x plus 1 and we know u is 3 sine theta. We don't really care about u, that's a dummy variable. So we can say x plus 1 has to equal 3 sine theta, right? And we want to isolate theta, so we can sub this back in. Big mistake, got the plus c, how could I? Anyways, so let's get theta by itself. This is going to be equal to x plus 1 over 3, and we're going to have to inverse sine both sides too. Equals theta. Okay, so now let's substitute this back in. We're going to have negative 3 of cosine of inverse sine of x plus 1 over 3 plus inverse sine of x plus 1 over 3 plus c. Okay, this is getting on my nerves. That is ugly. Let's fix that. So let's draw a right triangle. When we take the inverse sine of something, this is implying that, remember, SOHCAHTOA, opposite over hypotenuse. This is going to be x plus 1. This is 3, because that's what you're taking inverse sine of, right? This is just a ratio. That's what sine functions are. And take an inverse of that, you're finding out which ratio corresponds to what angle. So let's just say this is some arbitrary angle theta, right? If you're taking the inverse side of that, we're going to get this arbitrary angle theta. And if you're taking the cosine of that, we're going to get the adjacent over the hypotenuse, and the adjacent is 9 minus x plus 1 squared over the square root. And you see that because this is Pythagorean theorem. Something squared plus x plus 1 squared has to equal 9. That was my mistake, I'm sorry. Has to equal 9, right? So that means 9 minus this squared has to equal that. So it's, and then we're finding adjacent over hypotenuse. So this over this, right? Yeah, it's this over this. That's what cosine is. So let's write that down. -3. We're gonna have a 3 on the bottom. These 3's will nicely cancel out. So we're gonna only get negative radical 9 minus x plus 1 squared plus inverse sine, you can't really simplify that anymore, of x plus 1 over 3 plus c.